For homework 5, part B, we'll start by writing out the balanced equations for the water and the propylene and the isopropanol and diisopropyl ether. So we'll start with our propylene, C3H6, and our water, which will create our isopropanol. Shoot. C3H7OH, which will then dimerize into C3H7OH, and it will need 2 of these, which will then result us with our diisopropyl ether. So C3H7, we'll have 2 of those, our oxygen in the middle, and we'll also get a product of water from that reaction, and those would be our balanced equations. So now we can move on to part B2, in which we can use those balanced reactions we just got and our initial flow rates and mole fractions for the diisopropyl ether isopropanol to calculate the extent of reaction and the flow rates of our products. So we can start with our water flow rate is 95 moles per second. I guess I should make sure I remind myself that it's the alkene and then our alcohol and our ether, and then our water is last. And our water composition, so our water Y will be NP array, and then it will be nothing, 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 and 1 for our water. We have our alkene flow rate, which is 100 moles per second, and our alkene composition, which is 1 for our alkene, 0 for everything else. Then we can do our stoichiometry of our reactions. So reaction 1, stoic, it will be, so our first reaction would be our water and our alkene creating our isopropanol. So -1, +1 here, nothing with our ether yet, and then minus water. Our Rx2, other array, and this time nothing's happening with our alkene. Our alcohol is we're getting rid of 2 of those to create 1 ether, and we're also getting water out of that. I think I put these in the wrong spot. Maybe it doesn't. Let's switch these quickly. And the last thing we need to determine is our molar composition of our products. So our ether X is another array, and we can go check what that's supposed to be real quick. So mole fractions of our ether, 0.1991 again, 0.001, 90%, 0.09, And this one says 0.01, so I'm going to keep it the same. I think it would make more sense for it to be a 0.9, so it adds up to 1. And then we have our alcohol X, which is our NP array. And then what values was this one? 1, 1, 94, 49. That looks right. And that's all of our givens. What's wrong? Oh, yeah. Should be all of our givens. And now we can create our function here. So our equations be a vector. Now we can unpack that vector into what we want. So our extent reaction 1, our extent of reaction 2, our ether product, and our alcohol product. That would be equal to V. So our flow rate coming in, or our feed, will be equal to our water F multiplied by our water Y plus our alkene F multiplied by our alkene Y. Our reactions will be man, that slipped my mind real bad there, but extent of reaction 1 multiplied by our Rx1 stoichiometry plus our extent of reaction 2 times our Rx2 stoichiometry, and then our products will be our ether X multiplied by our ether P plus our alcohol X multiplied by our alcohol P. And then this can return this will return our feed plus our reactions minus our products. And now we can use our root solver to find what values for our extended reaction 1, 2, our ether product flow rate, and our alcohol product flow rate will make this mass balance equivalent. So root of our function and our initial guesses will be 90 and ether 5 and 100. And this should give us what we're looking for. So then to get what we're looking for, we'll just go .x. And these will be our extent of reaction 1, so about 100. Our extent of reaction 2, our flow rate of our ether product, and our flow rate of our alcohol product. All right.